Good morning, students. Students, welcome to this second virtual video on practical chemistry. Today we will be doing the experiment number 2 with you. And in this titration and this video or in this experiment, we will again go for the titration of KMnO4 versus ferrous ammonium sulphate. Student, in the first video, we determined the value of X and the molecular mass. In this titration, we will try to determine the percentage purity. The process will be same. The strength of KMnO4 and the ferrous ammonium sulphate has been changed. So that naturally the titer value will also be different. So what is being given to you in this question? You are provided with two solutions as follows. A10 is a solution prepared by dissolving 1.80 gram of potassium manganate per liter. A11 is a solution prepared by dissolving 20.5 gram of hydrated ferrous ammonium sulphate solution in a liter of the water. Am I clear? So what is the amount of KMnO4 in a liter given? 1.80. Amount of ferrous ammonium sulphate in a liter given? 20.5. Now what will be the procedure? Again the procedure will be same. We will take a burette, clamp it in the clamp stand, fill it with the solution of a KMnO4 and up to the each 0 mark. Then in the conical flask, we will pipette 25 ml of ferrous ammonium sulphate. It will also depend upon the size of pipette provided to you. And to that we will add 20 milliliter of a dilute sulfuric acid. Shake it properly. Then add drop by drop KMnO4 solution into this conical flask till the persistent pink color is obtained. You will be repeating the experiment at least thrice to obtain the two concordant value. So what's the procedure? Rinse and fill the burette with a KMnO4 solution. Pipette out 20 ml or 25 ml of the solution A11 of ferrous ammonium sulphate into the conical flask. To this add 20 ml of A12 solution of a dilute sulfuric acid, especially provided for this. Now titrate the solution by running A10 from the burette till one drop of this solution gives a permanent light pink color to the solution. Am I clear? In the conical flask, the pink color should not disappear on shaking the content of the flask. Repeat the procedure to get at least two concordant reading. Now you must state the capacity of the pipette used and the titer value which you intend to use in your calculation. The equation given are KMnO4 when react with H2SO4, it will form K2SO4 plus manganese sulphate, water and oxygen. It will oxidize the ferrous sulphate to the ferric sulphate. You can see from the equation 2 mole of KMnO4 oxidizes 10 mole of a ferrous sulphate into ferric sulphate. Now we will be doing the practical which I will be demonstrating to you. We will be obtaining the titer value. Then the 4 question has been asked in this case. First is to determine the molarity of ferrous ammonium sulphate, then to determine the molarity of a KMnO4 solution, then to determine the concentration of KMnO4 solution and the percentage purity of a KMnO4 solution. I think I must be very clear what we are trying to do it over here. Now I will demonstrate to you how to carry out this titration work. Now student, I will demonstrate to you how to carry out the titration and how to determine the titer value. I will be demonstrating to you only once. The similar kind of exercise you have to do at least thrice or more to get the concordant reading. As you can see over here, this is a clamp stand and this is a burette. This burette is each up to the 0 mark. So I will clamp this burette in a clamp stand. Can you see this, students? I have clamped this burette in a clamp stand. Now what is to be done? I will add KMnO4 solution into this burette. This is a KMnO4 solution I will be adding into this burette. I will put a funnel over it and then start adding a KMnO4 solution. Close this knob tightly so that it does not leak up. Now we will add KMnO4 solution into this burette. You can see over here the KMnO4 solution is being added and is being added into the burette. Up to what mark? up to the 0 mark. You can see by keeping the burette in such a manner so that you can see easily the marking on the burette. It is marked from 0 to 50. So must be filled up to the 0 mark. Can see, students? So it is filled up to 0 mark. Like this. It is filled up to the 0 mark over here. Now you can remove this funnel from here. Now what is to be done? You may adjust this burette. This is a ferrous ammonium sulphate. I'll pipette out ferrous ammonium sulphate into the conical flask. Can you see this? So we will pipette out ferrous ammonium sulphate into the conical flask. See over here, it is being to be filled up to the each mark. Am I clear, student? Now I'll add this ferrous ammonium sulphate into conical flask. Just see over here. This ferrous ammonium sulphate is added into the conical flask. Now what is to be done? We will add dilute sulfuric acid through measuring cylinder into this conical flask. So now what amount of it is to be added? 20 ml. So you can take 20 ml of dilute sulfuric acid into conical flask, into the measuring cylinder, and then add into the conical flask. This is a conical flask. This is dilute sulfuric acid. We'll add into this. Am I clear, student? Now it is to be shaken slightly, and then it is to be kept below the burette, and KMnO4 solution is to be added into it in a drop-wise manner till the persistent pink color is obtained. Now see over here. This is a clamp stand. In the burette we have got the KMnO4 solution. In the conical flask we have taken the ferrous ammonium sulphate and added dilute sulfuric acid into this. Now we will add KMnO4 solution into this conical flask drop by drop till the persistent pink color is obtained. It must be shaken continuously till the persistent pink color is obtained. So add in a drop-wise manner to obtain a persistent pink color. You may see over here, I am adding KMnO4 solution into this so that I can obtain the persistent pink color. Persistent pink color can be obtained over here. Is it clear? So that we may obtain the persistent pink color. The color must not get decolorized by shaking. And whensoever the persistent pink color is obtained, that will indicate the end point of the titration. That will indicate the end point of the titration. You can see over here, I am continuously adding KMnO4 solution into the mixture of ferrous ammonium sulphate and dilute sulfuric acid. When this will get oxidized, it will result in the formation of a persistent pink color. Ferrous sulphate will be oxidized to ferric sulphate. Just see over here. Keep on adding KMnO4 solution with constant stirring till the persistent pink color is obtained. Keep on adding the KMnO4 solution into the solution in a conical flask, which is ferrous ammonium sulphate and dilute sulfuric acid. At one stage, you will definitely obtain the persistent pink color. Whensoever the persistent pink color is obtained, that will indicate the end point of the titration. You must keep on checking it whether the persistent pink color is obtained or not. Keep on checking it. Just see, is it obtained? I think few more drops are to be added. So I'll again add few more drops of a KMnO4 solution into this, so that the persistent pink color will be obtained. Keep on shaking, you will observe when it is getting changed or not. Now see over here, it is a very light pink color obtained. Very light pink color obtained, and is now not decolorizing. So that will indicate the end point of the titration. And if I read this reading, it is coming to be 23.7. So what is the titer value of this? 23.7. What you need to do, I have demonstrated by taking only one titer value. You will be doing it at least thrice. When you do it more than thrice or more than thrice, you will definitely have a concordant reading. If done very systematically, that concordant reading will be the titer value, and with that titer value you will be making a calculations to solve the various questions which is being asked in this titration. So what is the titer value in this case? We are obtaining a value 23.7. What is the size of the pipette? It will be 25 ml. Now students, after obtaining the titer value, what is our titer value? 23.7. We'll do the calculations for the various questions which is asked in this experiment. Now, what is being asked to calculate? We have to calculate the molarity of hydrated ammonium iron second sulfate solution, the molarity of KMnO4 solution, and the concentration of KMnO4 solution, and the percentage purity of our KMnO4 solution. Everything has to be done in a very systematic manner. As was asked in the question, it was asked to tabulate the titer value. So we will make the observation table. In this observation table, first will be serial number, then the burette reading in milliliter, the initial value and the final value, and the volume of KMnO4 used in milliliter. How? What is the initial value of the burette? 0 in every case. I have demonstrated to you to take only one value, but you have to do that determination of titer value at least up to 3 times, so that you may obtain the concordant reading. Initial value 0, 0, 0. What is the final value coming over here? 23.7. Suppose in the second experimentation also it comes to be 23.7. And in the third experimentation it comes to be 23.8. So what are the two concordant reading? 23.7. What will be the volume of KMnO4 used in the milliliter? It will be final minus initial. So 23 minus 7.7 minus 0, it will come to be 23.7. Similarly over here it will come to be 23.7, and in this case it will come to be equal to 23.8. So what is the end point or the titer value? It comes to be equal to 23.7. I think you must be understanding. Repeat the process 3 times at least to obtain at least the 2 concordant values that will be called as a titer values. From this titer value, I have to calculate these 4 questions asked to me. Now, first one is the molarity of hydrated ferrous ammonium sulphate. First of all, I will write down the formula. So, molarity of hydrated ferrous ammonium sulphate. Molarity of hydrated ferrous ammonium sulphate. How do I determine it? Formula will be strength upon molecular weight. What is the strength of ferrous ammonium sulphate? 20.5. What is the molecular weight? 392. So what is the value coming over here? After solving it up, it will be 0.05229 molar. Answer must be reported to the 4 decimal place with unit. Marking scheme in the board. A mark for formula. Mark for answer with unit. Am I clear? So how will we find out the molarity of ferrous ammonium sulphate? Strength upon molecular weight, this will be equal to 0.05229 molar unit over here. Now second is, we have to find out the molarity of KMnO4 solution over here. So molarity of KMnO4 solution. In the second step, we have to find out what is being asked in the question, molarity of KMnO4 solution. For the molarity of the KMnO4 solution, formula will be M1V1 upon M2V2 will be equal to N1 upon N2. M1V1 is ferrous ammonium sulphate, M2V2 is KMnO4 solution. What is the value of M1? M1 will be 0.05229 into volume of KMnO4 solution used. Remember, a ferrous ammonium sulphate solution used is the size of the pipette. What was the size of pipette? 25. Then M2. What is the titer value? 23.7. Solve this for M2. What is this 10? It is 10 mole of ferrous ammonium sulphate and 2 mole of our KMnO4 solution. So what will be the molarity value obtained over here? Molarity obtained over here will be equal to 0.01103 molar. Am I clear, student, over here? So molarity obtained over here will be equal to 0.01103 molar. Now third will be the concentration or the strength of KMnO4 solution. How do we determine this? It will be molarity multiplied by molecular weight. What is the molarity coming? 0.01103. What is the molecular weight of KMnO4? 158. So it will come out to be equal to 1.748 gram per liter. Fine. In the last part, we have to find out the percentage purity. Percentage purity will be equal to pure substance upon impure substance multiplied by 100. What is the pure substance? 1.742. Impure sample upon 1.80 into 100. So this is the pure substance we obtain. This is the impure substance multiplied by 100. It will come out to be equal to 96.77% over here. So what will be the value obtained over here? Percentage purity will be 96.77. Remember, in every question, first of all write down the formula and obtain the answer and write down the unit. Molarity of ferrous ammonium sulphate is strength upon molecular weight. How do you find out the molarity of KMnO4? M1V1 upon M2 V2 will be equal to N1 upon N2. How do we determine the concentration or strength of KMnO4? It will be molarity multiplied by molecular weight, which will come to be equal to 1.742 gram per liter. Percentage purity, it will be pure substance upon impure sample into 100. Solve it out to get the answer equal to 96.77%. This is how the calculation is to be done. So hopefully you must have understood the experiment number 2, which was again the titration of KMnO4 versus ferrous ammonium sulphate. So in the titration of KMnO4 versus ferrous ammonium sulphate, we have done with you the two types of calculation. In one calculation, we determine the molecular mass and water of crystallization. In second kind of titration, we determine the percentage purity. I hope this must be very, very clear to you. So with this, the first titration in the syllabus is being done with you, in which we have divided this into two parts or into the two experiments. All of you are expected, whenever you come to the lab, to do it physically and make the practical notebook of that. Thank you.